Hello everyone, I'm Dr. Nandy. Welcome to the YouTube channel Ecstasy of Physics. In this video, I'm going to talk about the content. Those are related to AP Physics 1, which is Algebra Based. Under AP Physics 1, we are having the 10 units and there are two sections in the questions paper. One is that multiple choice sections and other one is the free response question section. Mostly in this video we are going to talk about the kinematics and the multiple choice questions what we have got in the past papers that we are going to cover in this video. So let's start with the first questions. In the first questions is given that questions 1 to 3 relate to two objects that starts at x equal to 0 at t equal to 0 and move in one dimensions independently of one another. Graphs of the velocity of each object versus time are shown below. So here basically there are two objects are given whose motions diagram, those are velocity time graph, those are represented. So in case of the object A, there is the motions which is in between 0 to 1 second. It's maintained the same velocity, that means it's a uniform velocity, and in between 1 to 2 seconds however the velocity is negative but it is a constant velocity. And in case of the object B, in between 0 to 2 seconds whose velocity is continuously increasing but the line is not the linear, it's a non-linear line. So let's start with the first question. In the first question they are asking that which object is farthest from the origin at t equal to 2 seconds. Before starting, let's note that term that in case of velocity time graph, if we are finding the slope or gradient, that is going to represent the acceleration, because we know that acceleration equal to its delta v upon delta t, which is basically representing that change in velocity per unit of time, which means for velocity time graph, if we can find out the gradient or slope, that's representing the accelerations, and area under the curve of this velocity time graph, that is representing the displacement. We know that displacement, velocity equal to it's the rate of change of displacement, that means ds, that can be represented as v times delta t, where this ds stands for the displacement, v is the velocity, and dt stands for change in time. So from there these two informations we can extract. Now based on these informations we can analyze the first question. So in the first question they are asking the furthest from the origin at t equal to 2 seconds. Furthest means what should be the displacement with respect to the at t equal to 2 seconds from the origin. So let's discuss the object A. So object A, which is in between 0 to 1 second, it maintains the uniform velocity which is positive 1, and in between 1 to 2 second it maintains the negative velocity, that is negative 1 meter per second. That means if we can find out the area, in between 0 to 1 will be having the positive area, in between 1 to 2 seconds will be having the negative area. So from there we are getting that object A, this area in between 0 to 1 second, that is 1, and in between 1 to 2 seconds, that is negative 1, which means the total area, that is 1 minus 1 is 0, the meaning which represents that its displacement, it is equal to 0. The thing is, the object A, it will come back to its initial positions at t equal to 2 seconds. And what about now object B? In case of the object B, the graph itself is representing that it is having certain area under the curve, and that is positive. From there we can directly conclude that the object B is having certain displacement. So that means the options, that would be B, will be the final answer. Now the second one, which object move with a constant non-zero acceleration? Note that they have defined here constant non-zero acceleration. Earlier already we have defined that acceleration, that can be represented by it's a gradient of the velocity time graph. So which means in case of the first graph, means object A, whose velocity is throughout 0 to 1 second is constant, and in between 1 to 2 second is constant, that means the acceleration equal to 0 in between 0 to 1 second, and similarly in between 1 to 2 second is 0. However, we can consider that acceleration 0, that is constant, but specifically they have mentioned that should be non-zero, that means that A cannot be the answer. Now in case of the B, if this would be like the line which is representing here, that is representing the, it's not a straight line, it's the curved line, and the which means the slope throughout the line, that is not constant. Since the slope it is not constant, so which means from here we can say the object B, it represents the varying acceleration. It's not the constant acceleration, it's the varying acceleration. From there we can say that B cannot be having the constant acceleration. That means it's the final answer is D, neither A nor B. And in case of the third one, which object in its initial positions at t equal to 2 seconds, that already we have represented here. The object of A means object A, which is having the displacement that is equal to 0, which means the final answer here, the at t equal to 2 second, object A, it will return to its initial position. In the next questions we have, the graph above shows the velocity versus time for an object moving in a straight line. At what time after t equal to 0 does the object again pass through its initial positions? And the options are given here. So here also we have the velocity time graph. That means the same conclusions will be doing that the area under the curve of the velocity time graph is going to represent the displacement. So here we have to find out that when this displacement it is equal to 0, so that the object it will come back to its initial position again. So let's analyze one by one. In between 0 to 1 second, here you can check here we'll be having it's a negative velocity, which means the area under the curve that also representing the negative. That means it will be representing the negative displacement. To counter this effect, again in between some positive directions also, some velocity area under the curve that we have to represent, and finally we have to find out that what should be the exact position. So let's do one by one. In between time 0 to 1 second, the area that can be represented by, it's the half into height of this section, that is 1, and the negative 1, and the base it is 1 second, so it's 1. So from there we are getting the area that is half, that means displacement is equal to half meter. And in between 1 to 2 seconds, the area that is half into 2 minus 1, that's representing the difference in the time, that is representing the base, and the height is also 2. So from there we are getting that is equal to 1. That means the net displacement that is equal to 1, which means the total displacement, if you have to find out in between 0 to 2 seconds, that we are getting as negative half plus 1. After adding these two, we'll be getting that is equal to plus half, which means the displacement in between 0 to 2 seconds, it is having certain displacement which is already exceeded its origin positions, which means the final answer it should be in between 1 to 2 seconds. So some zones it will be coming whose area that will be representing, that will be countering the area, negative area in between 0 to 1 second. So the final answer here, that will be between 1 to 2 seconds, the object it will return to its original position. That's the options B. In these questions we have to find out a body moving in the positive x directions passes the origin at t equal to 0 between t equal to 0 and t equal to 1 second. The body has a constant speed of 24 meter per second. At t equal to 1 second, the body is given a constant accelerations of 6 meter per second squared in the negative x-axis directions. The positions x of the body at t equal to 11 seconds is, these are the given options. Now let's proceed with by drawing the this is representing the x-axis, these are the y-axis, and what are the given informations we have. So at t equal to 0, it says that it is passing through the origin. That means passes through the origin, that means s equal to 0. At t equal to 1 second, in between 0 to 1 second, the body has a constant speed of 24 meter per second, which means v equal to 24 meter per second. At t equal to 1 second, the body is given a constant acceleration of 6 meter per second squared in the negative x-axis direction. So due to which negative x-axis directions, I have considered that acceleration that is equal to negative 6 meter per second squared. That means these are the given informations we have. What we have to find out, the positions x of the body at t equal to 11 seconds. So at t equal to 11 seconds, what would be the position? That is, I have represented here that s. So that's the thing we have to find out here. Now let's start with, in between 0 to 1 second, it has moved with the uniform velocity 24 meter per second, which means we can use the equation of kinematics, that s equal to initial velocity into time t since the acceleration equal to 0, so the remaining half a t square term we don't have to write here. From there we are getting the velocity that is equal to, it is 24 times by 1, that is 24 meter. That's the displacement in between 0 to 1 second, which means it would be moving like 0 to, let's say it's t equal to 1 second, its position it is 24 meter. Now at this position, it's at these positions it is having the it has started accelerations with -6 meter per second square, and the total is t equal to 11 seconds. Already it has traveled the 1 second, that means the remaining 10 second it has to travel. So for this remaining 10 second, what would be its final positions, that I am trying to find out. So this is for 0 to 1 second. Now I am trying to find out in between 1 to 11 seconds what would be its position. So here s, initial velocity into time t, plus half into acceleration into t square. Initial velocity, that is equal to 24 times by t equal to, it's 10 seconds, because 11 minus 1 is 10 seconds, plus half into acceleration, that is -6 times by t square, so it will be 10 square. If you do these calculations, you will be getting from here, that is -60 meter, which means the total displacement in between 0 to 11 seconds, the total displacement, it can be represented by +24 -60, that is equal to -36 meter. In the statement, it's given that a diver initially moving horizontally with speed v dives off the edge of a vertical cliff and lands in the water a distance d from the base of the cliff. How far from the base of the cliff would the diver have landed if the diver initially had been moving horizontally with speed 2v? So let's consider this is a diver. However, actually I'm very bad in diagram, but still this is representing the diver who is standing here. So initially it's having the velocity that is equal to v, and let's consider the height of the section that is equal to h. Now this is representing the path, or you can say that it's the projectile motions which will be executed by the diver during its falling conditions. At present, in the given statement, it is given that it is going to travel the distance, that is d, from the base of the cliff. Now if the velocity, if it is becoming 2v, then what would be the positions of the diver, that we have to find out in this case. So here let's start with the vertical component of the velocity that I am considering as 0, because since the initially it's given that it's a horizontal motions, it's moved horizontally, which means the vertical component of the velocity that can be represented in the diagram by vy, it should be 0. So now from the equations of kinematics, we can use motions equations, that is displacement equations, s equal to ut plus half gt square. That is basically at present the vertical directions, the total height it is given by h, and the initial velocity along the vertical direction, that is equal to 0, and along the y directions is acceleration, that is same as the gravitational acceleration, so which means half into g into t square. From there we are getting h equal to half g t square, which means the time t equal to root under of 2h by g. From there we can conclude that the time is independent, the time of flight of this diver, which is independent from the initial velocity. So from there now we are going to find out how much it got displaced horizontally. So it would be d, that is equal to its initial velocity along the horizontal direction, that is represented by v, into time t, plus half into a into t square. But since the accelerations along the horizontal directions, it should be 0, so we don't have to consider the accelerations here. Now similarly, if we can find out how much it got displaced along the due to the 2v velocity, for the new positions it would be d prime equal to 2v into time t. that is equal to 2 into v into t, which means it can be represented by 2v. So this will be the twice of the, like option C, that would be the twice of the initial position. Now the questions which is related to projectile motions, where it is given a projectile is fired with initial velocity v0 at an angle of theta naught with the horizontal and follows the trajectory. Which of the following pairs of graph best represents the vertical component of velocity and accelerations v and a respectively of the projectile as functions of time t? So here it is given the initial velocity, that is v0, and the angle of projection, that is theta naught. So we can resolve this v0 into two directions, along the x and the along y. So let's define our coordinate system here. This is the x and this one is the y direction. So it's x and y, and v0 it can be resolved into two component along the x directions, that is the horizontal directions is vx, and along the y directions it is vy. Now in case of projectile motions, note that the accelerations along the x directions it is always 0. There is no accelerations along the y directions and x directions, and accelerations along the y direction, that is same as the gravitational accelerations, and which is exerted in downward directions. So here it is g, it is in downward directions. And this will be the maximum positions, and the maximum position there will be no vertical component of velocity, so it's vy, it becomes 0 here. It will be only having the horizontal component of velocity at this point. Now here we have to try to find out the vertical component of velocity and the acceleration. Since the acceleration throughout the motion is constant, so here we can say the acceleration that is represented by g only. So whatever will be the positions of the object, always the acceleration it will be same, that is g. And the vy, the velocity initially it is along the positive y-axis directions, and after some time when it has reached to the maximum height, its velocity it is equal to 0, and again when it has it is going to strike the ground, it will be having the same velocity vy, but it is in the opposite directions, and vx, the horizontal component of velocity, it will be remaining same. Now let's analyze the options. So in the first case, in the first option, the velocity which is started at initially time t equal to 0, the velocity that is equal to positive. So here also we are getting that velocity along the y directions, positive y directions, initially it is positive, and after some time when it has reached to the maximum position, the velocity is equal to 0. And since the velocity is continuously decreasing with the constant accelerations, acceleration that is downward directions and the velocity that is upward direction, so due to which the velocity is continuously decreasing, so it's the negative slope is representing, and once it is reaching to the ground here again, so it will be striking the ground with the same velocity. So this magnitude, if it is plus vy, this would be negative vy. So this first diagram is correct, but the acceleration throughout the motions we have defined here, that would be constant in case of projectile motion. Since the acceleration it is varying, it shows that it is varying, so which means this one is incorrect. Similarly, the B options also, by similar logic, we can say acceleration that is incorrect one. In the third option C also, the acceleration it shows that it is 0 acceleration, which is represented along the x-axis, but the accelerations along the y-axis, that is same as g. So here this is also incorrect one. So the correct one, it would be definitely D, because here the acceleration that is constant throughout, however it is a negative acceleration because of its downward directions. We are considering the upward directions is the positive, and the velocity already we have analyzed here. So here the final answer is D.